Today we're going to be taking notes on two-step equations. So up until this point, when we were working on substitution, we were given a value for x and we had to use that value to find the solution. For these problems, they're going to give us a solution and we have to kind of work backwards to find the value that x needs to be to make it true. So let's go ahead and just remind ourselves of the parts of our equation. So I have right here an equation here, 7x plus 15 equals 4. So let's go ahead and draw a box around the first term of the equation, 7x. Now in this first term, we have two parts. We have the 7, which is, remember, the coefficient. That's the number that is closest to that variable. Then the x is our variable, so go ahead and label that. That's whatever letter they're using and that they are telling you to solve for. And then we have 15, which is our second term, and that's our constant. So that's just the number that's getting added or subtracted. So when we are solving two-step equations, we're going to use a lot of inverse operations. And whenever I say inverse, I mean opposite. So let's go ahead and just remind ourselves of what opposite operations mean, what inverse operations refer to. So if we see addition in our problem and we want to undo it, we're going to use subtraction. If we see subtraction in our problem, we're going to use addition. Addition and subtraction are inverse operations because they are opposite of each other. If we see multiplication, its inverse is division. And kind of backwards, if we see division, its inverse is multiplication. So if I ever ask for the inverse operation, just think about what's the opposite. All right, let's look at our first example of solving here, or actually our steps, and we're going to go through it as we do this first example. So I have that equation that we just labeled, 7x plus 15 equals 4. Our very first step is to figure out where our variable is. So when I drew a box around that variable and the number with it, its coefficient, that's our very first step. And this is what we want to get alone. At the end, I want to have x equals and then its answer. So let's go ahead and draw some railroad tracks. So our railroad tracks go around the equal sign straight down. And this helps us keep the parts of our equation separate so that we make sure that we know what numbers are on the left, what numbers are on the right. Step number 2 says that we need to get rid of addition and subtraction using inverse operations. So remember, if I have 7 right up next to x, that's multiplying. And then it says that I'm adding 15. So if I want to get rid of that addition, I want to get rid of that 15 to try to get that 7x alone, I'm going to use its inverse, which is subtracting. So go ahead and write that you are subtracting 15. Now if I change one side of my equation, then I need to do the exact same thing on the other side. So I took away 15 on the left, I need to take away 15 on the right. And then I'm going to draw a line so I can find out what I have left. Well, on the left side, if once I had a positive 15 and I'm subtracting 15, so those 15s go away. Let's go ahead and just draw a line through them. They're gone now. So what's left is that 7x. I'm still going to have a balanced equation, so I still have equal. On the other side, I had 4, and I subtracted 15, so now I have negative 11. So now I'm on to step 3. I am trying to get rid of multiplication and division using inverse operations. So in this case, I'm multiplying by 7. If I want to get rid of that 7, I'm going to divide by 7. So draw a fraction bar. We do not use that division symbol anymore. We use our fraction bars. Divide by 7. And if I change it on one side, I've got to change it on the other side. Go ahead, and if I was multiplying by 7, now I divided, those go away, so I'm going to cross those out. They cancel each other out. Now I just have x on the left. On the right, I had negative 11. I'm dividing by 7. Well, that doesn't divide evenly, so I'm just going to leave it as that fraction. That works for my x. All right, let's look at our second example here. Now I have x over 3 minus 12 equals 6. So my very first step is to draw a box around that variable, the term that has the variable in it, and to draw my railroad tracks. And now I'm going to get rid of that extra number that didn't get boxed. So in this case, I was subtracting 12, and I need to use its inverse. So I'm going to add 12. And I'm going to do that on both sides so it stays balanced. Now, if I had subtracted 12 or a negative 12 and I added 12, those go away. Now I just have x over 3 on the left. On the right, I had 6, I added 12, now I have 18. And that is still a balanced equation. I still need an equal sign in the middle. Now look, I was dividing by 3. If I want to use the inverse, I'm going to multiply by 3. So I'm going to draw that multiplication dot and put a 3. Remember, if you're multiplying by 3, that's the same thing as 3 over 1. And I know that the 3's will cancel each other out. So I'll just have x on the left. Now, if I change the left-hand side, I need to change the right-hand side the exact same way. So I multiplied by 3. In this case, I don't need to put a little 1 on the bottom because it wasn't a fraction. 18 times 3 is 54. And I have my value for x. So if this was a test or a quiz, I want to make sure that I have the right answer. So I'm going to go back and check my work using substitution so that I can make sure that that value is true. So I'm going to put this back in that first expression. So I'm going to put 54 where x was. I'm still going to divide by 3 minus 12. And I'm going to try to make sure that I get 6 as my answer. So now I'm going back to GEMDAS. First, I would have to do that division. 54 divided by 3 is 18. Now I'm going to copy the rest of the problem. Now I can do my subtraction. 18 minus 12, that's 6. And 6 equals 6. So I know that I did that problem correctly because I went back and checked it with substitution. All right, let's look at our bottom two examples. These are where it gets a little bit tricky, but I'm going to use the exact same steps. So looking at the third example, 5 minus x equals negative 10. When I draw my box around my variable, I have to make sure that it has whatever was in front of it inside the box with its sign. So when I was subtracting x, that subtraction stays with x, not with the 5. And I'm going to go ahead and draw my railroad tracks. So I need to get rid of that 5 so that I have just subtracting x on its own, that negative x. If I had a 5, it does not have a sign in front of it. That's just a regular 5, so it's positive. If I want to get rid of a positive, I'm going to take away 5 so that I'm left with 0. If I'm taking away 5 on one side, I'm going to do the exact same thing on the other. And now let's see what's left. Well, positive 5 and subtracting 5 leaves me with 0. Those go away. I just have that negative x or minus x. On the other side, I had negative 10. When I subtract 5, now I have negative 15. Now, anytime you have a variable without a number in front of it, they don't always write this, but you can always put a 1 there. So I'm going to fill that in so it looks like a negative 1x equals negative 15. And now it's very clear which number I got to get rid of. I need to get rid of that negative 1. If they're right next to each other, they were multiplying. The inverse of multiplication is division, so I'm going to divide by negative 1 on both sides of my equation. And when I simplify, those negative 1's on the left will go away. I'm left with just x. On the right, when I have negative 15 and I divide by negative 1, I have a positive 15. And I have my solution because x is all on its own. Let's go ahead and check this because that was a tricky one. I want to make sure that it works when I put it back into the problem. So let's rewrite it. Instead of x, I'm going to use 15. So I have 5 minus 15. equals -10. I want to make sure that that works. Well, if I type 5 minus 15 into my calculator, I get -10. So my two sides are equal to each other. I know that that solution works for that equation. In my last example, I have a fraction. When we have a fraction, we want to start out the exact same way. I'm going to put a box around the term that has x in it. So in this case, it's 2/5 x, and draw my railroad tracks. So I can keep my parts of my equation separate. So I need to get rid of subtracting 3. The inverse of subtraction is addition, so I'm going to add 3 to both sides. Those 3's go away on the left. So now I just have 2/5 x equals 7 plus 3 is 10. So I have 10 on the right. Now, if I have a fraction here, I need to multiply by the reciprocal to get rid of that fraction. So let's remind ourselves what reciprocal means. The reciprocal of any fraction, so write this down up in that box, reciprocal, so of 2/5, all that we need to do is flip it upside down. So the 5 is going to be in the numerator, the 2 is going to be in the denominator. So I'm going to multiply that 2/5 x by 5/2. And I'm going to do the exact same thing on the other side. So let's look at the left first. So I have a 5 on the top and a 5 on the bottom that are going to cancel each other out. And the 2 on the numerator and the 2 in the denominator are going to cancel them out. So now I just have x on the left. On the right, I had 10. Remember, any whole number you can put over 1. And I'm going to multiply straight across. So I have 10 times 5 is 50. And 1 times 2 is 2. And before I write that that's what x equals, I need to make sure that it's simplified. So I need to do that division problem. 50 divided by 2 is 25. So I'm going to make sure that at the bottom of my equation, I have x equals 25 as my solution. And put my box around it. Let's check it with some substitution. So just at the bottom of that box where we have a little bit of space left, I'm going to rewrite my equation. So I'm going to put 2/5 and then in parentheses that 25, because remember, if they're squished together, I need to have the parentheses. Minus 3 equals 7. So the first thing that I would need to do is multiply that 2/5 by 25. Well, in order to do that, I need to put the 25 over 1. When I multiply straight across, I have 50 over 5 minus 3. So 50 over 5 minus 3, bring down the rest of the problem, equals 7. Division comes before subtraction, so I'm going to do 50 divided by 5 and get 10. And then write down the rest of the problem. And when I subtract 3 from 10, I know that that equals 7. So my work here works. That solution is true. Let's write ourselves a little note at the very bottom of our paper. If you have a fraction, if the coefficient is a fraction, you can multiply by its reciprocal. So we've seen a lot of examples on this video. We've seen some pretty normal examples, like our first two. Those are very typical problems you'll see. But we also saw some tricky ones, like where the variable comes second in the equation, or when we have fractions. So if you get stuck on a problem, you can go back to these examples and they will help you out. Make sure you have everything that I've written down on your paper so you have good notes to go back to if you get stuck.